Welcome to some notes on the graphs of sines and cosine functions. So far we have defined sine and cosine on the unit circle, right triangles, and a circle of any length. But originally we defined them on a unit circle. And we said that cosine with the x coordinates, sine is the y coordinates. Well, what we're going to do now, instead of making those two functions exist only in a circle or a triangle, we're going to actually let the angle that we are rotating off the positive x-axis actually be an input, like an x coordinate. So notice this is 0, pi over 2, pi, 3 pi over 2, 2 pi. And we are going to allow that to be a horizontal value. Like the angle that we're rotating is now just a horizontal number on the number line. And then the sine or the cosine will be the height. In this case, starting with sine, the y coordinates will be the height above or below the angle on the x-axis. So it's a little bit different to view it the way we've been doing it. We've been just looking either at x or y to get sine or cosine. But now we're going to look at what the graph looks like, how the pattern of these things look when we lay it out horizontally, the angles out horizontally. Alright, so I'm going to start off, let me get a thicker marker to make my points. I'm going to start off at an angle of 0 radians, which makes a sine. This is sine. A sine is the y coordinate of 0. So 0 radians produces 0 for sine. Alright, and then pi over 6, notice here's pi, and there's 1, 2, 3, 4, 5, 6 to get there. So this is pi over 6 right here. So at pi over 6, I've got 1/2. So at pi over 6, there's a half. Okay, now pi over 4 is not an actual tick mark on here. This is 1 pi over 6. This is 2 pi over 6, which will be pi over 3. That's the square root of 3 over 2. Square root of 3 over 2 is about 0.86, 0.87, somewhere between those two. So 0.866. So that would be a little bit higher than, this is 0.75, so 0.86, right around, be there. Okay, and then at pi over 2, we would get 1. Now if I wanted to put pi over 4 on here, I could, and there's pi over 2, there's 0, so pi over 4 would be right in the middle of those two, about right there. That's the square root of 2 over 2. Alright, so the square root of 2 over 2 is about 0.71, 0.70, so that would be about right. There's again 0.75, so right around in there. Okay, alright, and then we're coming back. As we come back, we're going to hit all of these same points again at the same intervals apart, meaning this is pi over 2, this is pi over 6 more than that. So I'm going to hit that at 2 pi over 3. I'm going to hit the square root of 3 over 2 again. So I'm going to be at that same height once again. And then that's going to be 3 pi over 4 right there, right between pi over 2 and pi. So I would hit about right there. Alright, and then again I'll be at 1/2 at 5 pi over 6, which is pi over 6 less than pi. So I'd be back at a half. Alright, and then when I get to pi, alright, that sine, the y coordinate is 0. So I'm back down to here. Alright, and now what happens to the y's after that? They dip down into the negatives. So the same thing's going to happen at pi over 6 more than pi, which is 7 pi over 6. I'm going to be at negative a half. Alright, and then the same thing's going to happen. I'll be at negative 1 down here at 3 pi over 2. At 2 pi, I'll be back to 0. Alright, and then these intermediate points. This is 1 pi over 6 more, 2 pi over 6 more. I'll be at negative square root of 3 over 2, which is almost to the top. So that'll be almost to the bottom down here. And again, because of the symmetry, I'll be like that. Alright, and then halfway in between these two is that 5 pi over 4, and 5 pi over 4 will have the negative square root of 2, which is like negative 0.7, so a little bit less than the negative 3/4 about, and then right there. Alright, so we get this wave pattern called a sine wave. And if I connect those dots, that's filling in the gaps in between the special angles, you know, for these values between 1/2 and square root of 2 over 2, and between those two. So we're filling in all the possible y values that we could get between those, all the way around the circle. Okay, now I've made myself all the way around the circle, so that's what we call one period. So one period of the sine wave is 0 to 2 pi, so 2 pi units is a period, what it takes to kind of get back. And then that's going from 0 to 2 pi, but remember, we can just keep going over and over and over and over and over again. And we just get this wave repeated as many times as we want to. Okay, so there's again what we just made. There it is. If we just keep on going either clockwise, counterclockwise, and just moving beyond 0 to 2 pi. Alright, so this is what we just did. The last one. That's that one period, but just notice it just keeps repeating in either direction. Okay, so as a function, and this is a function, remember, if you remember from pre-calculus 1, this passes the vertical line test, right? As the x-coordinate being the angle, and the output, the height, being the y-coordinate of the unit circle. That will always pass the vertical line test, even though it was originally defined on a circle that didn't pass the vertical line test. When we treat the angle that we're rotating as a horizontal input, now this thing does pass the vertical line test everywhere. So it is a function. And because we can just keep cycling around and around and around forever, we get a domain of all real numbers. Okay, it just keeps going to the left and right as far as we want to. Okay, the range is -1 to +1. That's the smallest it can be is -1, the highest it can be is +1 for the y values. And again, that's because we're talking about the y coordinate here, and the y coordinate never gets higher than 1, and it never gets lower than -1, but we do hit every other y coordinate in between those two somewhere on the graph. Every single y coordinate is hit. So that's why we're seeing that range. The period's 2 pi because that's how long it takes to get back to where we started. That's also because that's one revolution around the unit circle. Alright, and then this is something, another little subtle property of it, the odd properties and the symmetry that we get about the origin. So again, what that means is if a point AB is on the graph of the sine function, if we went from that point through the origin and then came out the other side the exact same distance, we would hit another point on the graph, and the coordinates of that other point would be -a, -b. So when AB is on the graph of an odd function, -a, -b is on that graph as well. Okay, so that's a property of the sine function. This is saying the same thing, right? Negative, the input is the opposite of what it typically we see it. We usually just see it as an x. So the input's the opposite, and that results in the output being the opposite. So -x, -y, that's another way just to say what I was just saying.